Welcome to Episode 41, System and Communications Protection, Part 1. At its core, this discipline is about boundaries that reduce blast radius, contain faults, and express organizational policy through the very structure of networks and systems. Boundaries are not just firewalls or filters. They are deliberate separations of trust, privilege, and function that prevent small incidents from becoming system-wide failures. When systems are isolated by purpose and governed by explicit rules, compromise in one zone does not automatically endanger another. The principle is simple but powerful: divide to survive. Boundaries protect not only data but also continuity, helping organizations absorb shocks gracefully and recover quickly. Building on that principle, mapping assets, flows, and trust relationships turns abstraction into a living model. Every environment contains devices, applications, and services that communicate, some routinely, others rarely. Mapping shows where data originates, how it travels, and which systems depend on which others. Include human and machine identities, since trust often flows through credentials as much as cables. For example, a diagram that connects databases, web servers, and identity providers reveals the real exposure paths beneath daily operations. Updating these maps after each major change ensures that defenses mirror reality, not outdated assumptions. Without this groundwork, controls risk guarding empty rooms while leaving doorways unprotected. From there, classifying data and traffic types brings precision to protection. Not all data requires the same safeguards, and not all traffic deserves equal trust. Classify based on sensitivity, criticality, and regulation. Routine application telemetry may travel with relaxed controls, while financial or medical transactions demand encryption and strict routing. The same logic applies to traffic direction. Outbound updates differ in risk from inbound user connections. Documenting these distinctions enables fine-grained policy decisions rather than one-size-fits-all firewalls. Over time, classification becomes a universal language between security, networking, and compliance teams, ensuring everyone protects the right things in the right ways. Extending that structure, separating user, administrative, and service planes keeps control channels distinct from everyday data. The user plane carries application content, the administrative plane manages systems, and the service plane handles internal machine-to-machine communication. Mixing them invites privilege escalation and confusion during incidents. Imagine an attacker who gains access to a web interface that doubles as a management console. The shortcut becomes a direct route to full compromise. Enforcing separate credentials, networks, and logging for each plane ensures that control paths remain privileged, monitored, and narrow. Clear separation prevents small missteps from becoming major control failures. From there, segmenting networks by risk and function enforces logical order in physical infrastructure. Segmentation groups systems with similar purpose or sensitivity into zones, each governed by specific access rules. For instance, development, testing, and production should never share unrestricted connectivity. Likewise, devices managing industrial processes should sit apart from office workstations. Segmentation acts as both shield and filter. It reduces lateral exposure and simplifies monitoring by shrinking the area that must be watched for anomalies. The smaller the segment, the easier it becomes to notice movement that does not belong and to respond before it spreads. Building on segmentation, controlling east-west movement between zones keeps breaches contained once inside. East-west traffic refers to internal system-to-system flows rather than external connections. Many organizations focus on the network perimeter but neglect these inner pathways, where attackers often linger unseen. Implement internal gateways or microsegmentation to mediate communication between sensitive areas. For example, a database zone should only accept queries from approved application servers, not from any device on the corporate network. When east-west traffic is both visible and limited, incident responders can track and halt malicious activity with speed and certainty. From there, gating north-south ingress and egress defines the formal boundaries of communication with the outside world. North-south traffic crosses into or out of the organization, and each path must enforce authentication, encryption, and content inspection. This is where external firewalls, reverse proxies, and secure web gateways play their most visible role. For example, inbound web requests might pass through a demilitarized zone that terminates TLS, screens headers, and logs transactions before reaching internal services. Outbound connections should also be constrained. No application should reach the internet unchecked. Gating both directions ensures the organization speaks to the world on its own terms, not an attacker's. Building on control precision, explicit allow lists replace broad wildcards to enforce intent. An allow list defines exactly which destinations, ports, or applications may communicate. Anything else is denied by default. Broad patterns like allow all outbound traffic create invisible risk because they grant permission faster than they can be reviewed. For instance, if a system only needs to reach 3 update servers, list those explicitly. Use automation to maintain the list, but keep policy decisions human-reviewed. Allow listing demands effort, but pays back in predictability. When communication paths are named, logged, and verified, they become trusted infrastructure rather than hopeful convenience. From there, terminating unneeded protocols and services trims the attack surface without adding complexity. Every open port, default service, or legacy protocol is a potential channel for misuse. Regular reviews should identify what is still required and disable what is not. For example, turning off unused remote desktop services or deprecated file sharing protocols reduces both noise and exposure. Document each termination so it can be revisited if functionality is later needed. Fewer services mean fewer patches, fewer alerts, and fewer surprises. Simplification itself becomes a form of protection that strengthens every remaining control. Building further, protecting application edges with gateways and proxies enforces consistent inspection at transition points. Application gateways understand the logic of the data they handle, such as web, mail, or database traffic, and can apply validation rules that generic firewalls cannot. Placing these gateways between zones or at external boundaries allows for protocol normalization, authentication enforcement, and content filtering close to the source. Imagine a web application firewall rejecting malformed requests before they ever reach business logic. Gateways act as interpreters of trust, turning policy into visible action where data enters or leaves controlled spaces. From there, inspecting encrypted traffic responsibly and lawfully balances visibility with privacy. Encryption protects confidentiality, but attackers also use it to hide malicious activity. Organizations must decide where and how decryption occurs, ensuring compliance with legal requirements and user expectations. For example, decrypting corporate traffic at secure gateways can expose hidden threats while leaving personal or external client data untouched. Responsible inspection requires transparency, consent where applicable, and clear retention policies. The aim is to see enough to defend without intruding beyond necessity. When inspection is governed by principle, not curiosity, integrity and privacy can coexist. Extending operational vigilance, monitoring path changes and route drift, detects subtle failures that open unintended access. Networks evolve continuously. New routes, redundant links, and dynamic protocols adjust paths in milliseconds. These shifts can bypass intended boundaries or expose data flows to new intermediaries. Tools that track routing tables, virtual network rules, and address allocations help spot drift early. For example, if a route suddenly sends sensitive traffic through a less secure segment, alerts should trigger automatic investigation. Detecting drift ensures that the network you think you have is the one you actually operate, preserving trust in every wire and rule. From there, documenting ownership, exceptions, and review cadence embeds governance into daily work. Every boundary and control must have an accountable owner who maintains configuration, validates compliance, and approves exceptions. Exceptions, temporary deviations for business needs, require documented rationale, compensating safeguards, and expiration dates. Reviews at regular intervals confirm that zones, routes, and rules still align with current architecture. Without maintenance, boundaries erode silently over time. Governance is what keeps them sharp and meaningful, transforming technical barriers into enduring policy expressions. In closing, boundaries express policy in wiring and code. They are not barriers to innovation, but the framework that allows innovation to occur safely. When assets, flows, and controls align through clear segmentation, explicit rules, and documented ownership, systems can evolve without losing trust. Boundaries embody the organization's philosophy of risk, how it limits impact, preserves integrity, and maintains order in complexity. A well-structured network is not just efficient, it is ethical in design, protecting both data and people by making trust explicit and measurable in every connection. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.